Hi students, welcome in the chemistry classes. So we are seeing the organic name reaction mechanisms. Today we are seeing the Kumada coupling reaction. Actually, Kumada coupling reaction is an organometallic coupling reaction because the catalyst that we are using here is an organometallic compound. Actually, that is palladium or nickel catalyst. Okay, we are taking palladium or nickel in the zero valent state. So actually, the Kumada coupling was the firstly discovered palladium or nickel catalyzed cross coupling reaction. Okay, cross coupling means we have taken two different compounds, and between these two compounds there is a formation of carbon carbon bond. Okay, new carbon carbon bond is being generated between the two compounds, two different compounds. In this way you are getting a combined, okay, or a complex molecule. Okay, so this is called the coupling reaction. Actually it is also known as sometimes Karash cross coupling reaction. So here firstly the question is, what are the compounds between them the coupling is happening? So actually we are taking two compounds. One compound is the alkyl vinyl or aryl halide, means you are taking a halide. Okay, and another compound is the alkyl alkenyl or aryl grignard reagent, means one time you have taken the halide and another one reagent that you have taken is the grignard reagent. Between them there is coupling. As a result, a new carbon carbon bond is generated, and this is happening in the presence of palladium or nickel complex that is in zero valent state. So see here, actually what is happening, you have taken this halide Rx. Now this R group, you are seeing this R group may be alkyl group. Okay, this may be a vinyl group or this may be a aryl group. Any type of group this may happen. And the second compound that you are taking is Grignard reagent. In Grignard reagent, you are seeing another R dash group. Now this R dash group that you are seeing, this may be alkyl group, a different alkyl group, okay? Or it may be alkenyl group, or it may be aryl group. Any group may be present. Now these two compounds are reacting together in the presence of a metal in zero valent state. This metal that you are seeing, this metal either may be nickel or it may be palladium in zero valent state. Okay, so the reaction is happening in the presence of a suitable solvent like THF or like BMF. Any one of them you can take. Okay, so as a result of this, what is happening, see here, this bond is being ruptured from here and this bond is being ruptured from here. Okay, means to say a new bond is formed between the two carbon atoms, two alkyl groups or two aryl groups, anything between them a new bond is being formed. So you are getting a coupled compound. Okay, and with which you are getting MgXX in this manner. Okay, so here the metal you are seeing here, this metal that you are seeing, metal in zero oxidation state, this is actually the nickel or palladium catalyst in zero valent state. Okay, this thing you should remember. So whenever you have given in this manner, just you should understand that this is the example of Kumada coupling reaction. Okay, so firstly see the mechanism. Just take a look of the mechanism, what is happening in the mechanism. Okay, actually it is a catalytic cycle because you are taking catalyst, so obviously you know that there will be a catalytic cycle. Now see, this is your complex. Okay, suppose this is nickel with two ligands in this manner. This is in zero oxidation state. This metal you are seeing is in zero oxidation state, means its oxidation number is equal to 0. So you can see there are two ligands, means its coordination number is equal to 2. Okay, whenever you are understanding the organometallic compounds chemistry, then you should know their oxidation state, you should know their coordination number, and you should know their electron count. So electron count here is actually 14 electrons. Now you can see that this metal is in very low oxidation state, means 0. Okay, means you can increase its oxidation number. Okay, secondly, its coordination number is also very low, means 2. You have given even 2. Okay, so it can also be increased, means this compound may undergo the oxidative addition reaction. So this will undergo the oxidative addition reaction. Oxidative addition reaction I have told you. So you can watch my lectures of the organometallic chemistry, you will get. And if you want the full course of the organometallics or inorganic chemistry or physical chemistry, you can view our app. Okay, I have recently launched my app, and where I have submitted all the types of courses. So you can take these courses in very low prices. So just you can visit, the link is given in the description box. Okay. So now oxidative addition is happening, means you need a compound. So firstly, our halide group is coming. Okay, this compound is being added to this metal. So what you are getting, this is our metal with two ligands. Two ligands are present at transposition to each other, and this R and X will get trans to each other. Okay, this you have seen in the oxidative addition. When you have given polar compound, then it will add in this manner. Okay, so you are getting a trans compound. Now the coordination number has been increased. It is becoming 4. Oxidation number or oxidation state is now +2, and electron count has also been increased by 2. So 16 electrons is now present. Now what you can do? This is 4 coordinated compound you have made. Okay, now the next compound that you have is the Grignard reagent. Okay, so actually this is being added with the Grignard reagent, means you are adding here RMgX. This is actually R-, because we have to take different alkyl groups. Okay, so actually when this R-MgX groups comes, actually what is happening? A new carbon metal bond is being formed. Okay, and this reaction, this is an important type of reaction that is called transmetallation. About that I have told you. Okay, so you can take my full course, you can see that thing. Okay, so this is happening, the transmetallation. Now as a result of transmetallation, what you are getting, this is metal and this is R group, L ligand, L ligand. Now what happens? This Cl will leave out, and on its place you will take R dash. Okay, so the leaving group will be here XMgX in this manner. Okay, this you are getting. Now you have seen that this compound that you are getting has two R groups at the transposition to each other, two ligands at the transposition to each other, means this is a trans compound. This is trans. Okay, so in the next step there should be cis trans isomerism, because we have to leave down subgroups. Okay, and the two groups can leave out only when they are cis to each other. So we need a cis compound. So there is the need of cis trans isomerism. Okay, so as a result of this cis trans isomerism, you are now getting this metal. R dash would come here, R come here. Ligand L comes here, ligand L comes here. Okay, in this compound, see here, oxidation number is again +2, coordination number is equal to +4, and electron count, if you are seeing, this is 16 electron. Okay, now in this compound the two R groups are cis to each other, means they can go out. This process that you have seen in this, what will happen? The oxidation number of the metal will decrease by 2. The coordination number of the metal will also decrease by 2. Okay, so actually this is called the process of reductive elimination. This is reductive elimination. Okay, so as a result of reductive elimination, you are leaving out R, R dash. So this is our product that we need. This is our product that you are needing, and you are getting your catalyst as it is. Okay, means you are getting now your catalyst. So in this way, if you are seeing this compound, see here. If you are seeing the whole cycle, just I am telling you, see here. In this cycle, you can see that there are 4 different processes happening. Okay, see here. One process is oxidative addition reaction. Second one that is happening is transmetallation. Third one that is happening is cis trans isomerism. And the fourth one that is happening is reductive elimination. Okay, so 4 processes are happening by which you are getting the product. Okay, now see some examples so that you can understand the whole concept. Suppose I am taking this one. In this compound, this is Br, means this is our halide. Okay, you can see, you can take any of the halide or you can take any of the Grignard reagent. Suppose I am taking this one Grignard reagent. Okay, in this manner. This is the Grignard reagent. Now these two are reacting in the presence of PDDPPF Cl2. Okay, and Et2. Means to say you have to see that the palladium or nickel should be bivalent, coordination number should be 2, and they should be in zero valent oxidation state. If this is given you, and you have given a Grignard reagent and you have given a alkyl halide, then what you have to do? You have to do the Kumada coupling reaction. Means you have to break down this group from here, this group from here. Just this thing you have to do. Okay, as a result, what you are getting? See here, you have made this thing. From it, you have to attach this one. Okay, from the side of this, from this side you have to attach. Okay, so you are attaching here. So you are getting this type of compound. Okay, so much easy. Now see the second example. See here, these are the two compounds that you have given, and these are treated in the presence of nickel with ligands. Okay, 2 to 5 mole percent. Okay, and you will get a yield of 69%. Okay, these whole examples I have taken from the reference books. Okay, so these will be very much beneficial for you. Okay, because from these the questions are generally asked in the competitive exams. So see here, this is your magnesium bromide on which you have attached this methyl group. Okay, you have to break down from here. Okay, and you have to break down from here. So you have to make a bond between this carbon atom and this carbon atom. So making a bond in this manner. Okay, you have made this bond, and again you have to make this halide in this manner. You have to make the halide. This is the upper side. Okay, in this manner you are getting the compound. Now see the third question. See here, you have given these two compounds. Okay, you are treating them in the presence of PdCl2 DPPB. Okay, and solvent is THF. You are refluxing it 87%. Then what you are getting? See here, the new bond is, see here, which group will leave out? Okay, so you have to break down this. This bromine can be leave out more easily. Okay, so you are getting here in this manner. This is your nitrogen. Okay, now see here, bromine is, this bromine is its ortho position, means you have to put it here. Okay, in this manner, and you have to make a new bond, and this group will leave down here. So just you have to put here a new group. This is the nitrogen and one bond here. Okay, in this manner, and here in this manner. So this is the compound that you are getting. Okay, now this compound can again react. This reaction can again happen. See here, if you are taking now this group. This group you are taking, and the reaction conditions are same. Means PdCl2 DPPB. You are taking THF. Okay, and refluxing you. Then you are getting, see here, again you have a new bromine present. So this bromine, you are seeing, this bromine can leave out. Okay, this bond can break down, and you are getting now a new compound. Means to say, in the same compound, what you have to do? This was your compound, and at this position, there was bromine. So you have to make a new group at this position in this manner. So you are getting this one compound. Okay, this will be your compound. Now see some more examples. If you have given ArCl, okay, and ArMgX, means you have taken aryl halide and aryl magnesium halide. Okay, means aryl reagent, Grignard reagent. So you are treating it in the presence of NiCO2 whole twice. Then this bond will break down, and this aryl group, this bond, this is ArCl, means this bond will also break down. So you are getting in this manner a coupled compound. Similarly, if you have given, suppose here is MEO and here is Cl. This is treated with MgCl. Okay, now I think you can do yourself. If you have given NiCOD whole twice, then what you have to do? You have to break down this group and this group. You are breaking down means you are getting in this manner MEO. Okay, this is the thing that you are getting. The two bonds are break down and you are getting a new coupled product. One more example here I want to tell you. This is your Grignard reagent and now you are treating it with this one compound in this manner. Okay. So just same thing you have to do. You have to break down these two groups. This reaction is happening in the presence of NiAC whole twice, THF as a solvent. So you are getting Cl. Firstly you have to write down the halide. Okay. So in this manner you will write down, you will make a new bond, then you will make the second one compound in this manner. So this is your product. So I think now you got clear, because this thing is very much simple. You can make this very easily. You have to just see if you have given a nickel or palladium complex with zero oxidation state, bivalent ligand. Okay, if you are getting this thing, then you have to couple the reagent, Grignard reagent and halide. Okay, and you have to make a coupled product. Okay, so there are a lot of examples in the books. If you want, you can comment me, and if you want the full courses, then you can visit my app. Okay, so please give me the suggestions which type of topics you want. Okay, so meet you in the next video. Thank you.